Welcome to the latest installment of the Aras Innovator Demo Series. Today, we're going to see Engineering Change, the digital thread in action. The demo series runs for 30 minutes and features all demo with no sales pitch. Each installment showcases a different capability of the Aras platform. During the webinar, everyone is on global mute. If you have any questions, please submit them into the questions panel within GoToWebinar, and we'll answer as many as possible in our Q&A session at the end. This demo is being recorded, and when the recording is available, you will receive an email with the link so you can share it with your colleagues or review it again for reference. We have on the line today David McDonnell, Solutions Consultant here at Aras. David, do you want to take it away?
Thanks, Brenna. Welcome, everyone. Engineering change, information. How quickly does your current system allow you to adapt your products to new information that signals the need for change? When you get new information, what can you do with it? Can you respond in a timely, actionable way? How long will that take? And how much of your product's information is really readily available for you to take action? Today, we're going to be looking at a fictional company called AR Robotics, who produces, sells, and services a line of robot arms for a variety of customer applications, including manufacturing, medical, and high tech. This is the AR3 robot arm, and we're looking at the bill of material structure or BOM structure. This concept has been around for quite a while, and most people in product development, including those outside of the engineering group, understand that this view is a relationship from one part to another, connections between parts. Today's PLM systems might establish a few more connections, say from a part to an engineering change, but much of the remaining view of the product lifecycle, including requirements, simulations, maintenance, and quality data, remains siloed away, disconnected, unavailable. Once products are manufactured and deployed in the field, this limited connectivity concept starts to falter, since each serialized item, robots in this case, will eventually get maintenance service and possibly component and software replacements and upgrades. To successfully capture and present this data for efficient use, the PLM system must track all of this information individually for each physical asset, creating a unique digital twin. Aras has created a platform and applications to allow all authorized users of the system to see each digital twin with a unique serial number and all of its unique configuration and history. I'm looking at the dynamic product navigator, and I can see each robot arm with its unique serial number. Expanding each subcomponent, I can see serialized sub-assemblies as well as components. In this case, I can see a component that's been replaced with the old serial number and the serial number of the new replacement component. Another view of the Aras Dynamic Product Navigator shows the serialized robot assemblies at the customer site with individualized work orders that have been issued against that particular unit. In this case, I can see this unit has had 2 work orders issued. And this work order had a problem report issued as part of its activity. Not only can Aras connect data from one piece to another, but it also has the ability to connect a discussion thread with each item in Aras. I'm looking at the visual collaboration discussion thread, which contains information such as rich content like markups, names and dates of the people that left the comments themselves, and even links back to items within Aras. I'm looking at this view here, and I think I want to leave a markup of my own. So I'm going to go to my robot assembly here. I'm going to stretch it out a little bit so I can see what I'm looking at. I can see these 2 components are the ones that I think I want to leave a note for. I'll go into markup mode. I can leave my note here. Let me put a couple leader lines in here to show exactly what I'm talking about. I can leave a comment. When I leave this comment, it becomes a permanent record within the Aras Innovator system, connected directly to this item. And now you can see my comments have been left here today with a timestamp. Let's go back and take a look at that problem report and use this as a kickoff point to see how I can look through the digital thread in Aras. I see my problem report here, and it's showing some errors on the diagnostics. The where used function shows that that problem report is connected to a corrective action plan. This corrective action plan is at the heart of the quality management system in Aras. This has information about the problem description, the cause, effect, and eventually the effectiveness of the actual corrective action plan. It also has links to quality events, including problem reports. This is the problem report that brought us here, as well as other problem reports that have been submitted against this particular corrective action plan. It has containment events, such as hold notices and stop ship notices to stop the problem from continuing. Analysis has root cause analysis, which I can see shows that there's a sensor overheating investigation ongoing. Corrective actions, including a rework order, and preventative actions, including ECOs and potentially quality documents getting issued to prevent this issue from occurring in the future. I can look at the structure browser to see a graphical tree grid view of this information, showing all the connections within the Aras Innovator system for this particular corrective action plan. Those connections allow a live 8D style report to be generated that shows all of the information regarding this quality event, including the quality events themselves, containment analysis, and the actions taken to correct and prevent this in the future. Now let's take a look at the ECO that was generated from this corrective action plan. The engineering change order shows the reason why this change is occurring because of an overheating environment causing a sensor failure. Here I can look at the workflow of this particular ECO, which graphically shows all of the activities in this workflow. Each activity also has different pathways it can take from one activity to the next. And these are voting choices for the person doing the activity. I can see who was assigned that activity. Sometimes it's a single person, sometimes multiple, even a group can be assigned the activity. Viewing the sign-offs lets me see a workflow history report showing each activity, its current state, who it was assigned to and completed by, how that person voted, in other words, which pathway through the workflow it took, and a time and date stamp of when each activity was completed. Further down in the ECO, I see the impact matrix. This shows all of the affected items within this engineering change. First, I can see the rotor motor assembly being removed and being replaced by another assembly 2449, which is the replacement motor assembly. This new motor assembly has a new surface treated casing as well as a higher temperature sensor within it. This impact matrix I can also see has automatically set the upper level parent assemblies to be revised. I can also see here that the electronic control unit has also been set for a revision. And within that electronic control unit, I see there's a piece of software. It's important that the software is connected with the electronic control module. Within the software item itself, there are connections to other included software, such as firmware in this case. And generally, the software item itself is usually built externally to Aras, but I can see that there's live links within Aras to the repositories for the software. Those can include things like Jira, GitHub, or in this case, Bitbucket. Dependent software is also tracked within Aras. I can see this particular software item has dependencies on diagnostic and flash tools. And documentation is stored here, where the version of the specific documentation is linked directly with the specific version of the software. These connections are critical to make sure that the software and the hardware are maintained in a state so that they are compatible with each other. One other thing I'd like to mention is I also see that this secondary motor assembly that's being replaced, or is the replacement, is also being released within this specific ECO. So we don't have to create another ECO just for the release of this new assembly. Graphically, I can see those connections in the Graph Navigator view. I'll open the software and simulation view, and I can see my robot arm assembly, expanding this out to subcomponents and subassemblies. And further down, I can see the software item that I looked at earlier, and I can open that item directly from this view. Also in this view, I can see that there's a simulation study that was performed. I can get more information on this simulation study here. I can see this study is linked to some of the requirements that were originally used to develop this robot arm, as well as a link to the simulation itself that was done initially for this first design. Let's take a look at what's in the simulation. The simulation is a thermal simulation. I see the link to the design that was used for the simulation. We can use design variables, in this case, such as the casing surface treatment. Here I see it's set to a value of polished. Environmental variables, such as the application temperature, with values and units that are specific to that item. And finally, the results of the simulation are captured in this view as well. And I can see that the sensor temperature at the simulation, the result was 69 degrees Celsius, which, based on the requirement values of greater than -25 Celsius and less than 75 Celsius, that target was automatically set as true, meaning the target was met. Simulations are rarely created from scratch. And with our overheating problem, there was several other simulations run. One that changed the casing coating to a black paint, and a simulation that ran with an increased temperature. Looking at the increased temperature simulation, I see that the environmental variable, the application temperature, was changed from the original value of 130 degrees to 220 degrees. And the results at the sensor temperature was 154, which the target was not met. And so that was set to false. I'm also able to see in the simulations the graphical results files, which include things like the meshing that was used to run the simulation, as well as the results files showing graphical temperature representations color-coded for both the gripper arm and the sensor itself. Finally, those two new paint casing coating, as well as the increased application temperature, were combined into a simulation where I can see the new surface coating is now black paint, changed from polished, the environmental variable from 130 to 220, and the results were met and set to true. All of that information can be viewed in the simulation compare document, which summarizes the results of all of the simulations, including the environmental and design variables used to run the simulation, the results of the simulation itself, and whether or not the target requirement was met as part of that simulation run. Looking at the actual replacement motor itself, I can traverse through the digital thread to see information regarding that motor and that specific version. Here I see the manufacturing process plan, which includes things like the engineering BOM that was generated directly from that version of that motor assembly. The manufacturing BOM, which is directly linked back to the engineering BOM and has dynamic reconciliation statuses to make sure all of the components are accounted for. And finally, I have the actual manufacturing plan itself, which includes operations, steps, parts, can include phantom assemblies, tools, and using the workbench, I can add even machines, documents, or personnel skills. This manufacturing plan is directly linked to a work document that's generated automatically from the items in the manufacturing plan. You can see that each time I click, it goes through to the work document itself. These work instructions can easily be published to a PDF format or even to an HTML format that can be served out directly through a wireless connection to a handheld device on the plant floor. This new motor is also linked to a technical document, which uses several of the same components, such as images and BOM structure from the manufacturing plan. These items, all linked back to the part, can all be traced back to the engineering change order to understand when and why that change was made. Finally, I have the ability to see my robot arm and traverse through each customer that has a unique serialized robot arm. And those serialized robot arms can further be traced to the work orders that have been issued against them, and whether or not those work orders have been opened, have been closed, or still remain open. And beyond that, traced to the actual component parts that were used as part of the service that was done as part of that work order. Engineering changes, information. You'll notice that I didn't search for anything while doing this entire demo. Everything I showed was connected with the digital thread inside of Innovator. This digital thread within the Aras platform will ensure that all of the data related to your product is connected and readily available for you to take action. Does your platform have the digital thread?
Okay, thank you, David. Make sure if you have any questions, you submit them into the questions panel. We already have quite a few submitted, so why don't we get started? David, is the digital thread a separate module of the Aras Innovator? And if so, is there an additional cost?
Well, the digital thread is not a separate module. It's a concept that is a fundamental feature that's built into the platform right at the ground level. In the out-of-the-box installation, the connections are the things that connect one thing to another and form the basis of a usable digital thread. But everybody knows that each business model is going to be different. So the easy configuration of Innovator to fit a business need will automatically let the user extend that digital thread into the new pieces that are configured to meet the specific business need. All of that is included in Innovator, and no, there's no additional cost.
Next, we have a question about software item. How is a software item the same or different from other item types in Innovator?
Each item type in Innovator is unique. They all have their different properties and workflows. Software item is different in the concept that hardware and software typically don't follow the same development process, just because of the nature of the way the engineering is done for those two types of items. But it's important that those two items are connected together as part of the digital thread so that there's traceability and a relationship from the hardware to the software to make sure that they're maintained in a way that is compatible. So in general, Aras takes care of the differences with the item types based on workflow and life cycles and properties and the connections and relationships between those item types.
I'm going to paraphrase the next one. It's about the discussion thread. For the discussion thread on the right side of the screen, does everyone have access to all the information in there?
That area of the screen, the discussion thread, is connected to specific items in the Aras platform. And the security based on the item that it's connected to will determine who can see the discussion thread that's connected to that item. But additionally, there's a feature, I didn't show it, but a feature where you can actually send discussion information and comments to specific users, and that then allows that discussion to only be viewable by the recipient that was initially kind of directed to in the discussion.
Moving on to our next question. Do customers have the ability to create their own graph navigator views? And if so, what item types are supported and what's involved in creating them?
I'm not an expert at this, but I know that there's a concept of a thing called a view definition and some view cards. The view definition basically controls what types of things, what information is pulled out of the database and is available to be displayed. And the view cards control things like what it looks like once it gets pulled out of the system. In other words, in the graphical navigator, you saw the, maybe I can pop it up on the screen here. What appears here and the connections between those are defined by the view definition, and the view cards define, what appears in this box and how big the box is and what color the box is and things like that. It's really the administrator's responsibility to define all that. That's not a user function in Innovator. I suppose it could be allowed to be defined by users, but it's not hard, but it's not trivial. All of that is explained in our configuration class that's included for subscribers. So it's not that it's very secretive or unknown, and it can be done for any item type in the Innovator system can have a graph navigator. It only makes sense for things that are connected with some sort of relationship, so you can see graphically what the relationship is between those items.
Okay, so it looks like we have another question about software item. Regarding the software item in the robot arm assembly, is that handled as part of the normal engineering change workflow?
The ECO that I showed during this demonstration showed a workflow that basically, let's see how fast I can pop that up really quick. Here. This workflow is CM2 compliant, and it has very specific steps to get through the workflow for everything involved in that impact matrix. And I guess the question might be this draft changes, which is basically to the person that's actually going to do the thing that is the engineering change. And again, software and hardware and even electronics are really three different disciplines, not even within the Aras system. It's all assumed that this one person is going to do all three of that, and that's probably not typically what's going to happen. So this workflow could easily be modified to branch out things in parallel so that when this start work happens, it goes to three different activities, one for the software design, one for the hardware design, and one for the electronics. And all three of those people can coordinate together, and then it would all branch back in together once all of those three activities have been completed. That would be what I think would address that issue about handling them all together.
Okay, great, thank you. Can the Aras digital thread capture information outside of the Aras software?
Well, as I showed with the software item, that link to the repository outside of the Aras system was a connection to that. Aras has a federation service that's part of the platform that can synchronize data from outside systems, either on demand or just continuously. And there are connectors that can be set up to handle those types of back and forth communication between outside systems. And depending on what that communication is, the digital thread can lead you to that information. And if the information is populating correctly from the external system, the digital thread will be maintained and you'll have all the information within Aras at your fingertips. The actual work and or files themselves may not reside in there, but the information available of where that is and what state it's in can easily be tracked within Aras.
Okay, great. Thank you, David. Unfortunately, that's all we have time for today. For any of those questions we did not get to answer, they will be addressed directly within the next few days. Before you go, I'm going to leave you with our upcoming demo series topics. On June 25th, there will be a demonstration on an innovative approach to managing simulation using Aras Innovator. And then on July 9th, there will be a demonstration on connecting system models in digital thread using Aras Innovator. You can register for upcoming demos and view any past demos at aras.com/events. And we'd love for you to join the Aras community at community.aras.com. There, you'll find blogs, community projects, and forums, all with a lot of great information. And be sure to connect with Aras on LinkedIn, Twitter, Facebook, and Instagram, where we share the latest updates and news, product information, and more. We thank you for joining us today and look forward to having you visit next time. Have a great day.